Hi, my name is Tim Mao and I'm the Global Customer Solutions Manager here at x-Rite. I'm here to talk to you about two instruments, the x-Rite eXact2 and its predecessor, the first generation eXact instrument. Now, what we'd like to talk to you about today is the fact that what matters to you is precision in these devices. If you buy multiple instruments, you expect them to read the same. And we have a term for that. If you have multiple exact ones, that's inter-instrument agreement. And you can look at our website on our spec sheet and find out the inter-instrument agreement of this device on BCRA tiles. And we have the same thing available for the eXact2 instrument. But what we don't have published is agreement on things that you might actually measure, ink on a substrate. And so I want to talk to you about some testing that we did to quantify what those results are. The testing that we did involved the following. We had multiple devices of each type. We had many different samples on a variety of different substrates, including paper and paperboard, film, and corrugated. We measured all those samples, and then we could calculate what was the inter-instrument agreement between multiple exact ones on those samples, and what was the inter-instrument agreement on eXact2 devices on that same set of samples. And then further along, we will talk about something else called intermodel agreement, which then starts talking about how does the eXact1 and the eXact2 agree with one another. So let's dive in. So let's talk about inter-instrument agreement. To refresh your memory, that's talking about how do multiple instruments of the same type agree with one another. So you'll see the numbers that reflect how well multiple eXact1 instruments compare to one another on a variety of substrates. And you can see that it really doesn't matter what substrate we're on. We are very close to the reported inter-instrument agreement of the device on BCRA tiles. So we get good agreement if you're sticking with this model of instrument and measuring across a variety of substrates. You're going to get good agreement between multiple devices. Now you can see the numbers that represent the same results, same exact set of samples measured now with multiple eXact2 instruments. And again, the numbers are very good. They reflect the fact that you can trust a multiple group of these instruments, a multiple fleet of instruments to measure samples and have good agreement between them. So from an inter-instrument agreement, or what's sometimes called IIA, we have very good results on printed materials with both the eXact1 instrument and the eXact2. But what about if you want to measure sometimes with an eXact1, maybe that's what created your standard, and sometimes with an eXact2, maybe that's what you're measuring with today, comparing back to this instrument. That's called intermodel agreement, so let's take a look at that. So now we're going to move into talking about intermodel agreement. What happens if I create a standard with an eXact1 and I measure my trial with this eXact2? How well do they agree to each other? Again, using the same samples, measuring identical spots, we did that work, and you can see now the numbers that we got when we do that comparison. And we get pretty good agreement between these two devices when we're measuring on paper or paperboard, right, or corrugated. But if you look at the numbers on film, there's a reason we have them highlighted in red. It's not a good thing. Right? Nearly triple the difference when we go to a film substrate. So that launched us into discovering the why. And ultimately, what we found is it has to do with this. So an eXact1 instrument, you can see, has a black circle in its shoe. That's for your targeting, so you know anything inside the black circle gets measured. On an eXact2, there's nothing, because you're video targeting and the circle is there. Now you may notice this media flattener, but it's clear and its opening is very large, so it's having no real impact on the measurement. It's there to flatten a crinkled film sample, for example. Okay? Our ultimate solution then is something we're calling the media ring. And this is what an eXact2 with a media ring accessory attached looks like. And you can see that it's got a black circle in it, very similar to the eXact1. That circle, that black circle, is very important. And we're going to show you exactly why by looking at some samples that are translucent. So I mentioned translucency, and I want to help to explain that to you and demonstrate it to you. First, I want to point out that when we talk about translucency in a film sample, we're not talking about what you might normally be thinking about. How does light pass through a sample this way, right? If I were to hold it up and look through it, can I see through it? That's a kind of transparency or translucency. But what we're concerned with here, what happens in these film substrates, is translucency that goes this way. So light enters this surface and then spreads across the surface horizontally, so to speak. Now, we're using some tiles to demonstrate this for you because they can be captured on video for you to be able to see it. And what I'm going to use is something called a light probe. It's just a little light. And I want you to see what happens when I shine that light down on this blue sample. You can see that the light is there, you can see it coming, but it basically disappears because that tile happens to be not translucent. What happens when I shine it on the green, now you can see just a little bit of glow around that light probe. So it's got a little bit of translucency. When I go to the orange, you see all that glow around that probe. That's the translucency that's going on. That is what the media ring, the black ring in the media ring, is helping to control. The light that goes across that sample like that it goes out there, but it can't come back into the optics to be seen. The black ring in the media ring on the eXact2 mimics the black ring on the eXact1 and corrects the issue caused by that translucency. So we've seen how translucency is at the root of the problem for the agreement on film substrates. And now we're going to show you what happens when we put this media ring in place on an eXact2. And you'll see the results on screen, and you can see that we've essentially corrected that error that was existing between eXact1 and eXact2 on a film substrate down to the same kind of difference you get on other substrates. So we've eliminated that as a problem, reduced it greatly, and we'll also show you now on screen the numbers that reflect what happens if I put this on and maybe I switch from measuring on film to measuring on paper to measuring on corrugated back to film, and I'm measuring on a variety of things. You can see that with this in place, we aren't negatively impacting the agreement to your eXact1 on the other substrates. So it's the right answer if you're going to be measuring on those kinds of substrates, and it's there for you to be able to help get the agreement that you expect. So for more information about this topic or related things like instruction videos maybe on how to install the media ring when you get one, a white paper that dives even deeper into the technical details of what we discussed today, please visit us at x-Rite.com, or you can go to your My x-Rite account and access that as well. Thank you for your time.